Welcome back to Handyman Helpful Hints. Today we're going to look at fixing a broken Ryobi Reciprocating Saw.
Handyman Helpful Hints is a new channel. Please like and subscribe. Comment and tell me how I'm doing.
So I've used Ryobi tools for years, really enjoy them, haven't actually had any problems with Ryobi tools the entire time I've been using them, until now. I've had this Ryobi Reciprocating Saw since 2016 or so. It's worked great, but I recently used it to start chopping down small trees and limbing trees, and I think I put it under a little too much strain because the motor went out. So I was like, all right, it's an old tool. We'll go ahead and buy a new tool. So I went to a store and purchased a new version, the brushless version of the Ryobi Reciprocating Saw. And that's right here, this thing. Unfortunately, I only used it for like 10 minutes and then it broke pretty horribly. It broke like this. The actual shaft where the blade connects into, that shaft just snapped right off of that reciprocating saw. So I luckily was able to return it and was debating what to do. I needed a strong reciprocating saw, something I could use to cut down some small trees and limb, as I was trying to do with this one, and it worked pretty well until I blew the motor. But I had an idea. What if I replaced the motor in this? And lo and behold, I found a source online where you can buy replacement parts, including a motor, for all kinds of Ryobi tools. So we purchased a new motor right here. We're going to look at how to replace the motor in this Ryobi Reciprocating Saw today and see if it works. Also, let's take a look at the old broken motor. Here is the motor assembly, including the speed controller and trigger and the motor. And we're gonna take a look at this motor, see what's going on with it. So if I spin the motor shaft, I can actually see that something's not spinning. The fins inside of there are not spinning. And if I spin the motor shaft on the new motor, I actually feel some resistance of the motor and also can see the fins spinning. So I'm going to bring you in close so you can see what's going on. Here's the old motor, and you can see I'm spinning the shaft, but the fins in there are not spinning. Also, it's pretty dark and burnt out. Clearly something definitely failed inside of there pretty catastrophically. Here's the new motor, and we can see that the fins are nice and white on the inside, not all burnt up. Also, if I spin it, you can see that they're moving. So definitely it's the motor. Now, let's plug them into a power supply and see what happens when I put some power onto them. I've got a bench power supply right here. We're just going to plug these in so we have some leads and use them to power our motors. All right, let's turn that on. What are we at? 18 volts. All right, well, they're 18-volt batteries, so that should be good. Let's try actually plugging into the speed controller portion of the assembly where the battery would go. So I'll just do that and then that to connect to both leads. And then let's press the button. Well, we can see we're drawing about 5 amps. And this is barely spinning, so that's definitely not great. Let's go ahead and try plugging in directly to this motor since it's not wired into the speed controller right now. So I'll connect up one side there and connect the other. Oh wow, that definitely spins much faster. If I just put those leads on, we're only using about 1.8 amps. So only using about 1.8 amps to get that nice speed out of there is definitely better than that one. Clearly, this is a broken motor. Now that we've confirmed the new motor works, let's go out to the workshop so that we can solder in the new motor. First, let's take this tool apart. I've got to see if I need to replace the wire because I did cut it and it might not be long enough now after I solder it. We're going to need a Torx 20. bit to get into the tool. So let's crack it open. Here's the inside of the Ryobi Reciprocating Saw. This is the reciprocating mechanism, and the motor goes up in here and then turns a gear, which then moves the reciprocating mechanism like so. All right, let's go ahead and solder that new motor in. So first I'm going to route the motor back through how it was previously and see where the cables go. Oh, I see. Okay. Under this metal plate right there. Got to take out the other screw. Whoop! It went somewhere. At least I saw where it went, and got a magnet. Got it right here. Okay, wire this down under there. Yep, that fits nice, goes in there. So I can run the wires just under here. And over through here to then just place the trigger mechanism and speed controller right here. Excellent. Now, part I'm concerned about is the battery clip, where that goes and if those wires will still reach, but it looks like they'll probably be fine. So now I have to figure out how the battery clip went in again. Oh, I see. Looks like goes in up here. And then these wires route down here. And they route under the metal plate that goes here as well. There's not a whole lot of room for me to be able to get this wired back in and soldered back in. So I'm going to use just a little wire on the side over here to take up the space that I cut off to strip these wires and use for a different project. I only seem to need, I don't know, an inch or so of wire, maybe 2 inches, possibly 1.5 inches to fix this. So I've got some wire here. It's actually a little bit thicker wire, but it'll work fine since I don't have to run it through these wire channels. All right, now I've got 2 small jumper wires that we're going to use to put in line to make the battery connector wire long enough again. So I'm going to turn the soldering iron on to get that warmed up and then clip off some of the extra wire from these. Since I started working on a wood surface, I figured I would use a metal tray to use under the soldering area to protect the wood. So we're going to just dip these in a little bit of flux. Now I could go mechanical and solder, so I guess I might do that just to have good connections. It's always better than just one or the other. So we will separate the strands of the wire and then kind of wrap them together just a little so we can get a mechanical connection and also a solder connection. Now I think the iron's warm enough to use. Let's get to soldering. Feels good. Now, since I'm not a savage, I'm also going to use some heat shrink tubing, which I would always suggest to use. Could go get my heat gun, but, well, maybe I will. Let's get the heat gun. I've got the heat gun, and we'll use that after we get both sides soldered together. So again, we'll split the wires, the strands here, so we can kind of tie them together, get a mechanical connection. And now we'll flow some solder over it. That seems horribly enough good to work just fine. All right, now we'll put some heat shrink around that. All right, and then we'll get the heat gun so that we can shrink the shrink wrap. Now, let's actually replace the motor. We've got some heat shrink tubing to cut away so that we can access the terminals and unsolder the wire from the old motor. All right, now we've got to solder the wires from the speed controller back on to the new motor. Don't forget to put your shrink tubing onto your wire before you actually solder it to the motor, because of course you can't get the heat shrink tubing onto the other side of the wire once it's soldered on. And you want to move it kind of far away from where you're soldering because you don't want the heat to start to shrink it before you're ready. Now it's time to solder back on the battery connector to the speed controller trigger assembly. I'm going to cut away the old wire, and then we'll just see if we can solder in the new wire. Dip it back here in some flux, put some flux on solder points, and now we'll solder it back together. Tin up that wire first, maybe a little bit. Great. Also, let's put some heat shrink tubing on this side as well, so that we can have nice heat shrink tubing all throughout. Now that we have it all wired together, let's give it a test. Nice. That looks like it's going to work. Okay, let's put it back into the enclosure. Alrighty then. Glad we were able to fix this tool rather than buy a new one. I like to save money where we can, and I'm sure you do too. Let's do a cost breakdown though of fixing the tool versus buying a new one. The motor was $25 from partswarehouse.com, and shipped it was $35.86. So, pretty good deal on a motor. Now, let's look at buying a new one. The brushless reciprocating saw that I purchased and broke in 10 minutes, that was $139. Okay, yeah, it broke. I didn't like it that much because it broke. Would have been nice if it didn't break. But if we were to replace with this same model reciprocating saw, it's normally $79. So $35, $79, we definitely saved a little more than half the cost by replacing the motor rather than buying a whole new tool. Unfortunately, there's actually a sale going on right now for only $39 for this tool. And they run sales occasionally for these tools. So I basically saved $4 by doing all the work to replace this motor rather than just going and buying a new tool from the store with a new warranty and everything for only $39. If it were its normal price of $79, I think we would have come out ahead, even considering time spent fixing it. For a few reasons. One, we're saving the environment by not filling up our landfills with broken tools, only small motors, so we're definitely saving some space there. And in the grand scheme of things, we did save money by replacing the motor instead of purchasing a new one. So I'm happy with the result. If you have ever fixed a broken tool and had an interesting experience with that, please give a comment below. You could also comment on how horrible those solder joints looked when I was putting together the harness and assembly of all the wires and motor and speed controller and such. Also, please go ahead and help the channel grow. Give a like, thumbs up, subscribe if you haven't already, because we definitely need some more subscribers to keep growing and letting me know that you like this content. Until next time, have fun, make music, and woodwork.